So in this slide session, we will look at some of the current commercial technologies for virtual reality. Again, it won't be, I won't show you all the existing devices that there are currently available, but I'll try to give you an overview of the different kinds of devices that we can now use for experiencing virtual reality. So we'll talk about headsets, about cave environments, and different types of controllers for virtual reality. So for the headset-based virtual reality, we can actually have different kinds of headsets. There are some headsets which need to be connected to a computer. There are headsets which are standalone, so you can just put them on your head and you don't need to connect them to a computer. The computer is inside the headset itself. And there are headsets which are actually just placeholders for a smartphone. So you use your smartphone as the computer that runs the simulation and as the display for the virtual environment. This is one example, one of the most common headsets for virtual reality, for desktop connected. This is not the Oculus Rift, although you can also use that. This is from a different manufacturer, and this is the HTC Vive. And you see, obviously this is not a complete picture. You don't see all the cables, etc., that you need to connect. But this is the main headset. There are, of course, cables that connect the headset to your computer, mainly for video. So the video is displayed inside the headset. You have also headphones here on the sides. You have the controllers. So these are the handheld controllers that you use to interact with the objects in the virtual environment. And you also see here in the back these two black devices, which are actually part of the tracking system. So in this headset needs these additional devices, which are not exactly cameras, but they are laser emitters that allow the headsets and the controllers to determine their position in space. So that then the position of your head, the position of your body, of your hands through the controllers are correctly mapped to the 3D space of the virtual environment. Another example, so this one is the Oculus Rift. So it's not the original Rift device that was created after the Kickstarter campaign, but it's a very much more recent version of the device. And you see that essentially it's similar to the previous device, with one crucial difference that I'll mention in a minute. So this is the headset with the headbands to hold on to your head. You see the cable that connects to the computer. You see the controllers. They have a different shape, but they are essentially controllers with buttons so that you can grab and move virtual objects inside the virtual environment. One crucial difference between this device and the previous one is that in this device, the positional tracking, so the way that the device knows where you are in 3D space, is calculated through these cameras. So the device has a number of cameras, 2 here in the front, 1 to this side, another one to the other side. And these cameras are able, with obviously software running on the computer, they are able to create a map of the room you are in, and then they are able to calculate the position of the headset in 3D space. And they do that also for the handheld controllers. So they help the system know where each controller is in 3D space. And actually, HTC also has a version which with this kind of tracking. So this is an alternative way of tracking, positional tracking for these headsets, virtual reality headsets. Another example, this is the Oculus Quest. This one is a standalone device, so you don't need to connect this to a computer. The computer is inside the device itself, so you can just load your virtual environment and it will run there without being connected to a computer. And it's similar to the previous one, with the exception of the cable. So you see, it also has cameras, here 2 at the bottom, 2 at the top. It also has controllers, which are not showing completely here in the picture, but it's essentially a standalone version. So it's able also to detect your position in 3D space and the position of your controllers. And then there are these kind of headsets. The one I'm showing in the picture is Google Cardboard. And so this is the very low end of these headsets. Basically, what you do with these headsets is you open them up and you place your smartphone in. And then you run the software, the virtual reality software, on your smartphone. So basically, the headset is just an enclosure for the smartphone with the lenses for the stereoscopic vision. And then you just place this on your head. There are versions of these headsets, and I'll show you one later on, which are made of plastic, and they're very, very cheap. You can buy one for about 20 euros. And they just hold a smartphone. Basically, any smartphone can be used for virtual reality. Some of these headsets come with controllers. Others don't come with controllers, so you just move your head and you point with a cursor at the center of the screen. There are also these portable virtual reality glasses, and you can imagine that these they are not very good for the experience. So if we think about the physical immersion of the user, these ones are much worse than the previous ones. But they are good for development because you don't need to keep putting your smartphone inside the headset. It's much easier to develop a virtual reality experience for a smartphone if you can touch the screen on your smartphone and then very quickly just test your environment without having to put the smartphone inside a headset. So obviously they're not very immersive because there's lots of light coming in, but they're very, very quick for development purposes. Then we have, I already talked a bit about this on another session, we have also projection-based virtual reality. And this basically is called the CAVE, which is Cave Automatic Virtual Environment, or sometimes called computer-aided virtual environments. And also, I show you a picture in another session, and here I show you a different picture. So a cave is basically a small room with 3 or 4 or sometimes more projectors projecting on the walls of the room, sometimes on the floor, as in this case, sometimes also on the ceiling. Sometimes the room is just a cube. Sometimes the side walls are a bit open to the sides, as in this case. But it's basically projection-based virtual reality. Usually, when you are inside one of these, you need to wear glasses in order to have stereoscopic vision, and you need to wear a controller so that you can interact with the objects in the virtual environment. As you can see in this case, these systems also usually use a positional tracking system so that they know where the user's head is, and so that the projectors can adjust the perspective of the environment to the position of the user's head. So they need a tracking system. In this case, in this picture, you can see, for example, the controller has these small dots here and here, and these are basically reflective markers that are then used by these cameras here and here to determine the 3D position of the controller and of the user's head. You see here also another marker. Cave environments, they are not often used for home virtual reality, obviously, because you need a special place, a special room to be set up for this. So it's not something that you can easily create in your home. These are usually used in universities, for example, or in companies that need to provide virtual reality experiences. Then we have controllers. So we talked a bit about headsets and projectors to experience virtual reality. But we need also controllers to interact with the environment. And there are different types of controllers that you can use for virtual reality. I'll show you just a few examples. The most common ones, if you are using a virtual reality system such as the Oculus or the HTC that I showed you earlier, the most common ones are this kind of controllers that you hold in your hands, and these are what's usually called 6 degrees of freedom controllers. What it means is that there are 6 parameters that the system knows about the controllers. It knows the position in space, so the X, the Y, and the Z position, and it knows the orientation, the rotation of the device, the rotation in the X, the Y, and the Z axis. So 3 plus 3, 6 degrees of freedom. So the system knows precisely where the controller is and how it is rotated in 3D space. Here's another example of the 6 degrees of freedom controller, this one from the HTC Vive. So basically the same thing, although the controller, the physical form is very different. Then you have what is sometimes called 3 degrees of freedom controller. These are often used with smartphone-based virtual reality, or with some of standalone headsets also have these controllers. Because these are 3 degrees of freedom, what it means is that the system is only able to know how the controller is oriented in 3D space. So it only knows the rotation about the X, the Y, and the Z axis. It doesn't know the absolute position of the controller in 3D space. So you can't, for example, you can't easily with this controller, you can't reach, you can't move your controller further to try to grab an object. Usually you just point with the controller and press a button. Then there are also this type of controllers which actually don't require you to hold a physical device. They basically do hand tracking through computer vision techniques. This is one example. This is the Locomotion device. And the Locomotion device, the device itself is a very small thing that you can attach to your headset. And then the device basically has two cameras that are able to understand the position of your hands in front of the headset. And so here you see, for example, that the hands of the user is being tracked and the virtual hands are being represented here. You see there in the screen behind the user. So you see that the pose of the hands, how the fingers are, where the fingers are pointing, is being calculated, is being determined by the software, and it's rendering an approximate model of the hand. And actually, hand tracking is something that commercial virtual reality systems are introducing into their own headsets so that you don't need an additional device. So the Oculus Quest, for example, the device I showed you earlier, it has those 4 cameras, and those cameras can also track your hands so that you don't need a physical controller. You can just use your hands and they are converted to a virtual representation of your hands, and then you can just grab and manipulate virtual objects. So here you see the virtual representation of the user's hands, and you see that is doing like a pinch gesture. This could be used, for example, to grab an object, a virtual object, and manipulate it. Then there are specialized controllers, and I'm just going to show you 2 of these. These controllers, they are not for manipulating objects with your hands. They are for moving about the virtual environment. So they are Locomotion controllers. Locomotion is one of the big challenges in virtual reality is how do you move through your environment in a natural way. And so there are a number of specialized controllers for doing this. One of those is this Virtuix Omni, which is essentially like a treadmill, but without moving parts. So it's basically a low friction surface where you wear special shoes, also low friction, so that you can walk inside the device. And your movement is tracked by the system so that it understands in what direction you are trying to move. So basically you simulate that you are walking, but you never leave your physical location. You just move your legs, and that will produce virtual movement inside the virtual environment. And then of course you can have additional controllers depending on the application. So in this case, the user was probably running a shooting game. So you have like that firearm in order to shoot at enemies inside the virtual environment. Another very, very specialized controller for virtual reality is the Birdly. This is for a different type of locomotion, as you can imagine. This is for flying around in virtual reality. So if you are flying in the virtual environment, then you need a device where you can kind of lie down. And it's not easy to see here in this picture, but the user is actually wearing a headset. So this would be an Oculus Rift headset, desktop connected headset, and his hands are on the wings of the device. And the way to fly in the device is actually to make um, flying gestures with your arms, so as if you were flapping your wings, and that will make you move through the virtual environment. The device can tilt. It's not easy to see from the still picture, but you see this area here. This is able to tilt the device in various directions so that you really feel that you are turning, for example, while you are flying. And you can also feel the wind in your body, because this part here at the very end of the device, this is actually a fan that can rotate with different speeds so that you can feel the wind in your body. So obviously this is a very, very specialized device for only one type of locomotion, for flying around. But it's a nice experience to have in virtual reality. So this ends this very short overview of current technologies that you can have for virtual reality. I tried to show you only commercial devices, so things that you could actually buy if you wanted. Some of them, if you had the money, some of those Locomotion devices, for example, they are quite expensive. But they are available nonetheless. There are, of course, lots and lots and lots of other devices that have been prototyped, but they are not exactly commercial devices. They are experiments done in research universities, for example. Uh, so I just wanted to give you an overview so that you understand a bit more of what is possible in virtual reality and what is currently out there for experiencing virtual reality.